Alright, in this video I'll be covering the integral of sine of the natural log of x, so if you want to solve this problem on your own, pause the video here. Alright, so when we look at this problem, we see a natural log x. So this will be easier to solve if we got rid of it. So what I'm going to do is a substitution, so I'll let t equal to the natural log of x. When we take the derivative on both sides, we see dt equals 1 over x dx. Isolating for dx, we see dx equals x times dt. If we go back to our substitution, if we raise both sides to the power of e, we have e to the power of t equals e to the power of natural log of x, or x. So coming back here, we see dx equals e to the power of t dt. Going back to our integral here, we can rewrite this as sine of t multiplied by dx, which is equal to e to the power of t dt. So now you should be able to recognize this is an integration by parts. Notice when we take the derivative of sine, it's cosine. When we take the derivative again, we get negative sine. So if we do two integration by parts, we'll get back to our original integral since the integral of e is e. So what I'm going to do is I'm going to let dv equal e to the power of t dt, v equals e to the power of t. Now u equals sine of t. du will equal cosine t dt. So now we need to remember our integration by parts formula, which is given by u, the integral of u dv equals uv minus the integral of v du. Coming back here, we can apply this. So we have uv, so sine of t times e to the power of t is sine t e to the power of t minus the integral of v e to the power of t times du, which is cosine t dt. So that's cosine t e to the power of t dt. Finally, we just have to do one more integration by parts. So we're going to let dv again equal to e to the power of t dt. So v is going to be equal to e to the power of t. Now u equals cosine t. So du equals negative sine t dt. So applying our integration by parts formula one more time, we have sine t e to the power of t minus uv, which is cosine t times e to the power of t, so cosine t e to the power of t, minus the integral of, well, actually, this is a plus now because we have this minus here, v, which is e to the power of t times du, negative sine t, so we can actually, it's a triple negative, so we have sine t e to the power of t dt. Alright, so what I'm going to do is I'm going to label this integral as I. So remember, this expression is equal to I. So I'm going to rewrite this equation as I equals sine t times e to the power of t minus cosine t e to the power of t minus, notice this is our original integral here, so minus I. So 2i equals, I'm going to factor out e to the power of t now, so we have sine t minus cosine t. And now divide by divide by 2 to isolate for I. And I'm going to also undo the substitution, so t is ln of x, so e to the power of ln of x is going to be x times sine ln of x minus cosine ln of x. And don't forget to add our plus c here. So this is the final solution to the problem. Make sure to subscribe to the channel if you want to see more content.